Right now, a blinding thermonuclear flash is hurtling toward Earth at the speed of light, but the explosion happened during the Bronze Age. The source of this incoming light is a binary star system called T Coronae Borealis, or T CrB for short. It sits about 3,000 light-years away from our solar system. For the last 80 years, this star has been completely invisible to the naked eye, but any day now it is predicted to erupt, becoming as bright as the North Star. This puts the global astronomical community in a strange position. They are staging a massive, coordinated stakeout for a live, breaking news event that is already ancient history. We know this flash is coming because T CrB follows a predictable schedule. Its first recorded eruption was in 1217, when an abbot at Erzberg Abbey in Germany noted a star that shone with great light. Since then, astronomers have heavily documented two modern eruptions, one in 1866 and another in 1946. These events established a rigid, roughly 80-year cycle for the star's explosions. In 2023, telescopes recorded a distinct dip in the star's brightness. Because a similar dimming preceded the 1946 blast, researchers confidently predicted the next explosion would happen in early to mid-2024. We are now approaching March 2025, and the star is still dark. It is officially late, and that delay is creating massive tension across observatories worldwide. Amateur astronomer Leslie Peltier learned the cost of this unpredictability the hard way. He monitored T CrB for years, setting an alarm for late-night observations, only to miss the 1946 eruption entirely because he caught a cold and decided to sleep in on the exact night it exploded. Because the cycle is an average rather than a perfect clock, researchers cannot afford to look away. Relaxing their vigilance for even a single night risks missing what could be the greatest astronomical event of an entire generation. Standard supernovas end in total stellar destruction. T CrB is a recurrent nova, which survives its periodic explosions. This happens because T CrB is actually two stars locked together. One is a massive, relatively cool red giant. The other is a hyperdense white dwarf, a dead stellar core packing the mass of our Sun into a sphere roughly the size of Earth. The gravity of the white dwarf is so intense that it constantly strips hydrogen gas away from the outer atmosphere of the red giant, pulling that stolen material into a swirling disk. Over 8 decades, that hydrogen piles up on the surface of the white dwarf. The pressure and heat continually build until the gas reaches its ignition temperature, triggering a massive thermonuclear blast. This blast clears only the stolen hydrogen skin. The white dwarf remains intact, allowing the siphoning of gas to begin all over again. T CrB acts as a perpetual cosmic engine, repeating this violent cycle of accumulation and detonation every 80 years. This chart shows the star's emission wavelengths, and it highlights a major breakthrough from early 2025. Astronomers detected a sudden, sharp upward spike in both hydrogen and helium signatures. These surging chemical signatures indicate that the rate of material falling onto the white dwarf is rapidly accelerating. The system is on the absolute brink of an outburst. To catch the first photons of the blast, the global astronomical community has mobilized. They have locked the most advanced space-based telescopes onto this exact patch of sky. Down on Earth, ground-based systems like the Very Large Array are also pointing upward, waiting to capture a complete picture of the event across radio, X-ray, and gamma-ray wavelengths. Observing the universe requires immense patience, and waiting for these celestial events can take years. If you want to support our breakdowns of these rare cosmic phenomena as they happen, please like this video and subscribe to the channel. Humanity has never been this technologically equipped to observe a recurrent nova. When the explosion finally arrives, we will be ready to turn a sudden flash in the dark into a massive scientific harvest. This star map shows where to look. Locate Coronae Borealis, a horseshoe-shaped constellation between Hercules and Boötes. The eruption will alter that crown. A new point of light will appear, burning roughly as bright as the North Star. This naked-eye visibility will be incredibly fleeting. It will shine brightly for a few days before fading back into the darkness for another 80 years. For that brief window, anyone who steps outside and looks up will share the exact same altered night sky witnessed by medieval monks and 19th century astronomers. Light from this explosion travels 3,000 years across the void before reaching our telescopes. This means the physical thermonuclear explosion driving this modern scientific frenzy actually occurred 30 centuries ago, near the end of the Bronze Age on Earth. We are pointing our most advanced gamma-ray observatories and space-based mirrors at an event that predates the Roman Empire. We are the generation lucky enough to intercept this ancient cosmic message. We just have to wait for a ghost to light up our sky.